Well, good afternoon, everyone. George Symons, the CEO of Gridstore. And what I wanted to do is, in many ways, not different, hopefully a little bit different, in talking about software-defined data center. Gridstore being in the storage space, going to focus much more heavily on software-defined storage. So we'll take it from the context of the data center. And, you've heard compute, virtualization, some good comments on the network and software-defined networking. So we have those two pieces. And with storage, probably the biggest difference is we're reacting to what's happened today, which is virtualization. And virtualization, I'll go into a lot more detail, has really changed storage. It's changed how storage needs to react to applications, how storage needs to provide performance. And then you heard about the cost of storage. That's clearly a piece of it. I can't tell you the number of customers I've talked to who do want to leverage more commodity hardware, and a lot of it is very much around cost. So those are sort of the key tenets of it. If you think about it, virtualization in many ways has changed everything, and in other ways has changed nothing. If you think about the hypervisor, the applications, the virtual machines on top, they see just what they've always expected to see down below. If you think about storage, underneath the hypervisor, it sees what it's always seen up above. So in many ways, both everything has changed and nothing has changed. But what's important is we have broken traditional storage. Right? It used to be very simple. You'd have storage connected to a server running an application. You would tune that storage for that particular application. It would work well. If it was a database and it wasn't working well, you'd be back in tuning the storage. And it was a one-to-one relationship that you could make very efficient. But with the advent of storage and virtualization together, we've seen multiple problems. Number one, right, the I/O blender effect. In other words, multiple virtual machines all hitting a hypervisor together. You couldn't no longer determine the sequence of I/Os coming into the storage. It was now all randomized. Secondly, the storage is now at the end of a wire that not only gets all these random I/Os from a single server, but it's getting, of course, the random I/Os from multiple servers, and the storage has become the bottleneck. We did a survey, and I've seen similar surveys done by analyst firms, to ask IT managers what is the biggest challenge they have with virtualization, and what came back was application performance. Right? How do I take the applications that used to perform just fine on a standalone server, now that I've virtualized them, I'm getting complaints. I have an application performance problem. It was interesting, the number 2 point was the cost of storage was too high. I actually believe those are if the math works right, basically the other 35 to 40% of people who actually solved their performance problem by over-provisioning the storage. So therefore, storage was no longer the bottleneck. I just put a lot more of it out there, but now it became a capital problem and a cost problem. So if you dig down a level deeper, what you see is the traditional LUN no longer makes sense, right? If you look at a storage array, you have the control plane there, you have the data services, you have the data plane, you have the storage itself, and you create a LUN, and that LUN gets served up to a server. Well, in a virtual environment, that LUN is now supporting a large number of virtual machines. So you can no longer set up the LUN the way you used to and run services for that LUN the way you used to, because it's for a specific application. Now the applications don't have anything to do with one another. So you no longer have a LUN that is tuned. You also, from a data services point of view, if I'm snapshotting that LUN, if I'm replicating that LUN, whatever I'm doing with that LUN, I'm now doing in general for a large number of virtual machines. The whole concept, when we say virtualization is broke storage, is the concept of the LUN and how that gets brought up to the server side of it. Right, many to one. So at the end of the day, you have poor performance, right? The applications aren't running the way you expect them to. The management complexity now is much larger because I'm not managing just a LUN. I need to manage the applications associated with that LUN, but I'm not given the tools to do that with. And the general answer to everything is over provision. Put more capacity, put more flash, put more whatever I need to keep the applications running well, because that is, the whole purpose of IT is to deliver a service to the organization so those applications run well. If you start to turn this upside down and you look at software-defined storage, there is a different way to do it. So what you do, and you've heard the concept with, again, networking, separate the control plane from the data plane. So move the control plane up to the virtual server. Okay, so now you're starting to run software on the virtual server. This is getting us to software-defined storage. The data plane itself could sit on the storage, could also move up to the server. The whole idea is that you start to create these virtual stacks of a virtual machine all the way down into the storage. You go back to where we were with an application or a server directly connected to storage, and you tune the two of them together. So what we're trying to do here is have that one-to-one correlation between a virtual machine, and it's an interesting question depending where you sit. If I talk to an infrastructure person, their goal is to create a virtual machine that has a service level and turn that over to the application person. So, they want to know that we're managing everything on a virtual machine basis. If you talk to the application person, he doesn't care about any of that. He has an application, he wants a bucket and a service level to put that application in. Reality, it's the same thing, it just depends on which side you look at that from. But I need that virtual machine to be able to deliver a known service level, a certain level of performance, certain level of reliability for an application. And that's what I mean by putting the management or the control layer above, so that I'm controlling it on a per virtual machine basis, and then the data plane so that the data gets managed all the way down to the storage on a per virtual machine basis. This allows you to do a number of other things. It allows you to optimize I/O on a per virtual machine basis, right? Whether, am I dealing with small random block reads and writes? Am I dealing with streaming data? Each one of those is going to be managed differently. And then when I take the data services and I add them above the virtual machine, I can now, on a case-by-case basis, apply those services. So, do I need to replicate this virtual machine, or do I not, right, as a part of a DR instance? Compression, am I willing to save on storage space and compress that data? Deduplication, you name it. Whatever the particular services are I now do them per VM versus doing them as we used to on a per LUN basis, right? So this is what I mean by turning it upside down and managing, using software-defined storage in that context. The big issue here, aside from cost, right? We all talked about that, whether it's better utilization, whether it's commodity hardware, is around management and making it easy to manage. I need to be able to do all of this on a policy basis. I want to set a policy and then be able to define this virtual machine is managed by this policy. And that defines the services that I get. That defines the performance of the underlying storage that it needs, right? The type of caching potentially that's done. Any of these can be defined on a service level basis on a per virtual machine. Then it can be managed efficiently, right? The complexity comes when I'm trying to do all of this, yet managing with older technology, older tools that weren't designed for this virtual environment. So, at a high level, right, virtualize the storage stacks, allow me to optimize the I/O on a virtual machine or an application by application basis, get predictability back into the system. Don't require the user to over provision to get that predictability, but let the system work it, use software to understand where the data is coming from, which virtual machine that data is coming from, how that data should be managed, where that data should be placed, end to end on that. Simple and efficient management, and then scalable. So that's the last piece of this is, and what was the number this morning? 60%, storage is growing by 60%. I don't know the number, and it's on a case-by-case basis, but I can assure you storage is growing, and it's growing rapidly. And it's not going to stop. And as you virtualize and start to bring everything together, one of the biggest challenges when I was working with VMware many years ago was how are we going to make virtualization the solution in the data center if I don't have high performance, low cost, scalable storage? Right? That was when, this is going back to Paul Maritz's days there at VMware, that was his biggest concern as to how he was going to penetrate the rest of the data center with virtualization. That was getting in the way. And it's taken till really today, give or take a year, to find the different technologies that allow that to happen, and allow that to happen efficiently, allow that to be easy to manage, and allow it to be scalable enough to really work in those environments, right? We can't all put an EMC DMX in there to manage, the rest of our applications. You need high performance, scalable storage in order to do that. From a Gridstore point of view, just so you know my bias in talking about this, we've built a system like this. We focus very specifically on Hyper-V as far as the virtual environment. Honestly, the reason is it's easier to fit into the operating system than it is with VMware, so that was our first target. But we put a virtual controller in each of the hypervisors. We connect it to commodity hardware, which has our own software on it, so you have end-to-end control. It scales out using a grid. We do know where the particular IOs are coming from, which virtual machine. We can prioritize, we can optimize, we can deliver quality of service, and I think you've heard a little bit about that today, but I think it's one of the key drivers going forward is quality of service. Again, not all applications are created equal, so if you do want to be like a service provider, you want to be able to offer different SLAs at different costs to your customers, so you want to be able to deliver quality of service. The same thing is true inside the data center, right? Virtualization causes noisy neighbors that can bring your entire network to a crawl or your storage to a crawl. So you need quality of service to give an unfair advantage to the business critical applications and quiet down the non-critical applications that may be overusing. But again, has to be simple and easy to manage. And then scale out. We use commodity hardware, we put software on it, we provide that scale out solution. So that's really what I'd put together today. I've been going relatively fast, so happy to answer any questions you might have.
Anyone? Questions? Oh, Dave Meyer.
How do you see this trade-off space between the optimizations you were just talking about and the complexity that is incurred?
Well, good question. So first of all, complexity should always be in the software, not for the administrator. If the administrator has to do any of it, it's more than can be handled. That's really where I think a big problem is today, is try to find a storage admin, let alone a virtualization admin, who knows what the performance or the IOPS required of any individual application. It's just not there today. So the software has to be able to do those optimizations itself. It has to be able to recognize patterns coming from, it's easy relative to see, am I getting streaming data, am I getting random IO, and optimize based on what you see. It does have to be automated. It can't be admin imposed. Now, the complexity it adds to the software and what CPU it takes and all is the other trade-off. For the most part, these aren't heavy CPU items, and the performance gains you get completely offset any additional CPU that you use to do these optimizations. So, my answer is keep it away from the admins. They can't and shouldn't be involved in that.
Any other questions for George? If not, we will actually be really close to being back on time. And I'll also, we'll go ahead. Don't forget that we'll also have George up at the close of the session to answer any questions you might have thought of between now and then.
Quick question, how the scalability is going to be, because it's parallel and you have to replicate lots of data between different nodes. So when you scale large scale, so the complexity actually as software service became very unhandleable in certain case. Another thing is for virtualization, we using live migration a lot. So in this case, how the live migration is going to be handled, and what type of limitation is going to be occur?
All right, was that last migrations?
Live migration, like vMotion.
Okay,
Yeah.
perfect. So the first question, scalability. We've addressed it because I do see scalability as a real problem. If you look at scale-out storage architectures in general, they're either clustered environments, and clustering has a real limit because of the inter-node communication. You tend to see clusters at 4 nodes, maybe 8. 16 is really pushing it there. The other option is replicating data. So you write to a node, it uses a back-end network to replicate to 1 or 2 other nodes. That again, when you start to get to a very large environment, you hit a cliff that with enough activity you're going to fall off that cliff. We've approached it differently. The reason we call it a grid architecture is we take advantage of the software layer up on the host servers, and we write in parallel to the number of nodes that are part of that virtual LUN. So let's say we're doing a simple 2+1 RAID. We'll break up the write into 3 chunks and write in parallel to 3 nodes. So there's a coarse metadata that is shared between the nodes that the server side has, so it knows where to write, where to read from. And that way we continue to scale where in reality we actually just get more CPU, we get more network bandwidth, and of course more capacity as we scale. Becomes a very linear activity. But that is one of the biggest challenges. How do you address that? And we've chosen this grid method to address performance. As far as migration, things like vMotion, to me, that's why you want still network attached storage. We're seeing today some of these converged platforms. I think you're going to hear from one of them shortly. And vSAN is the one I pick on for lots of good reasons. But you need to replicate the data to be able to migrate to it. With the network attached, the data is just a virtual LUN that you're mounting as you move from one server to another in that environment. So for large scalability, the migration is very easy, whether you're using vMotion or anything of that nature, to be able to move from one to the other.
All right, I think that will just about do it. George, thank you very much for your time. We really appreciate it.
Thank you.